Hello everyone. Today we will examine the effect of humidity on filaments and how stale filaments affect printing. One of the most frequently asked questions I've received since I first started this job is how should we store our filaments? Do the filaments we leave outside deteriorate? How much does this affect the printing quality? Theoretically, I knew their effects and was always trying to answer the questions. However, I had never directly tested the difference between a newly opened filament and a filament that had been left outside for a long time or exposed to moisture. This video is that video. I approached the subject from three angles. One is a filament kept in a vacuum bag with silica gel. The other filament has come out of the bag but has been highly neglected, either left on the printer or just put here and there. The other one seems quite pleased to continue its existence as a filament. It has had a great time, more than any filament could ever have, exposed to plenty of water, at times thoroughly washed, and has had a good time as a PLA filament. Returning to the topic of the video, I conducted all the tests I did with PLA filaments produced for speed. I did a test print with a filament I haven't used in ages. Let's review the first prints immediately. I think we all use Benchy Boat as a test print. What you see here are PLA printings that have just come out of the vacuum bag, left here and there for a month, and the other one has been exposed to high humidity. All printings were taken with a high-level printer like Bambu Lab X1C. Frankly, I was definitely expecting the difference to be significantly more, but the appearance of the filament, which was left in the water for days and even exposed to steam, was very little. I also did a stringing test with the same filaments, because this is one of the most common problems encountered with stale filaments. As you can see, the difference between the filament waiting in the vacuum bag and the one exposed to moisture was again small. During this process, I took the ambient humidity very seriously. I bought two humidity and temperature meters, one mechanical and one digital. I wanted them to check each other, and indeed, they both gave similar results. The atmosphere of the house was generally around 35–40% humid. It's not bad for a living environment, but it's above my standards for filament. In my research, I generally learned that it is efficient for filaments to be in a humid environment in the range of 10–15%. Of course, the humidity can vary greatly depending on the season and the conditions of the environment you live in. The result I got in a month could lead to very different results in a different environment. Now we continue to examine the prints I received after waiting for a month in this humid environment we just saw. I wanted to work on a larger model with more detail, and I did the printing of the elephant model you see. Such a nice printing. This is an incense burner. You put incense on the film nose, the incense burns and falls into the chamber on top. I downloaded the model as STL Flicks. You can purchase a membership for models like this. It's a platform I've been using for a long time. When we look, differences are almost negligible. The surface quality is extremely successful in every model. I can only observe that when held to the light from different points, the filament that has been waiting in its vacuum bag has a more silky appearance, and the color of the filament exposed to intense humidity is a bit more mottled. You can only see this if you indeed force yourself to really see a difference. It may not actually even be very clear in the photos I took for you. There's also a minimal amount of stringing formed between his teeth. I don't think these are visually significant. They can be cleaned by hand within a few seconds. During these tests, I wasn't expecting much difference between the filament outside for a month and the one from the vacuum bag. But I wasn't expecting such a small effect from the filament I was waiting to root after soaking it in water. So if the filament stayed in the water a bit longer, the sugar beet would slowly start to sprout. I said I'll keep these filaments under the same conditions for another month. I kept the filaments for another month and took the same test printings again. There's no need to print again if it's in a vacuum bag. Removing filament from a vacuum bag a month before or after doesn't affect quality. After 2 months, while there was no change in the filament I kept in the cupboard here, the printing taken with the filament exposed to moisture showed a slight increase in stringing. The same situation also occurred in the stringing test. There isn't much change in the filament waiting in the cupboard. However, we can see a slight increase when exposed to humidity. Another model I got the printing of is a vase consisting of a single wall. I thought it could give us an idea about the change in surface quality, and it turned out just as I thought. The printing surface of the filament in its vacuum bag is flawless. It's very close to flawless for the filament outside the box. However, in the printing taken from the filament left in humid environments for 2 months, there are many streaks. You can't notice this at first, by the way. The printing looks quite nice to your eye, but especially when light is held from behind, you could see the deteriorations in quality. I mentioned conducting tests with a high-end printer like Bambu Lab X1C. I suggested trying with an entry-level device like Creality Ender3 V3 KE due to potential printer variations that can affect the results. That's what happened in some parts. There's no change in the filament waiting in the box. There's no fraying. The surface quality is quite successful. Slight stringing formation occurs on filament outside box. This amount increased slightly more on filament exposed to moisture. These you see were test models I made after letting the filament sit for a month. In the bench printing I took 2 months later, a slight increase in the stringing rate of the printing taken with the filament I left outside was observed, while the printing I took with the filament exposed to humidity for 2 months was where I experienced the most intense problem among all the printings. Let's take a quick look at the stringing test. The same situation is also here. After 2 months of waiting, these prints also show the same increase in stringing. The filament has started to stringing and structural deformations have begun to appear at the sharp parts. This result at the end of 2 months is a printing problem and needs to be corrected. How can we fix this situation? Many brands have these types of filament dryer machines. Mine is a simple model. You put the filament in, set the time, and it heats the filament and removes its moisture for the set time. The dryer I have is one of the old models. It can only be used for PLA, but I did the measurement. Ideally, it keeps the PLA around approximately 50 degrees and reduces the ambient humidity ratio to 10%. Creality introduced a very nice model for this. You can dry with special settings for each type of filament. Also, the new model looks attractive. It will be sold soon. When the products arrive, I'll include a link in the video description. 10% humidity is pretty good for PLA. Under these conditions, you can continue to use your filament without it going stale for a long time. I tried to restore the filaments that had previously gone stale by drying them later. Now let's see what results I got after drying. When we look at the stringing test, we can say that the stringing problem has not been completely resolved, but even though formal distortions had already begun before drying, there was an improvement after drying as if it had returned to its state a month ago. In the Benchy boat model, the positive difference is more. While there was serious stringing in the last printing I received, you can see that there is even less stringing than the first printing I received after the drying process. I think the drying process has worked significantly here. Perhaps much better results can be achieved with the newly released drying devices. I also see users who make their own drying devices. These will certainly be useful too. There are also those who do drying in ovens that cook food at home. But the oven resistor may not be sensitive enough, and the flame that overheats can be completely deformed. It can burn and release poisonous gases. Therefore, he does not find this method very healthy and does not recommend it. The effects you see can vary depending on the environmental conditions and the type of material. For example, PETG is more quickly affected by moisture than PLA, and deterioration in printing starts faster. If you have nylon filament, you open it and use it. A few weeks later, you say, let's do another printing, but the result starts to turn out very bad. Because it is a type of filament very quickly affected by moisture in nylon, and it is essential to dry it before starting to use it. But it seems like there's no need to exaggerate the issue too much for PLA. It appears that it can be stored for a long time in a place where it doesn't directly see the sun, like in a closed cabinet where the humidity isn't too high. Lastly, I want to show you these printings as well. I don't even exactly remember when the filament that I used in the printings is from, but I'm sure it's over 2 years. I've left some filament at the bottom and I couldn't bear to throw it away. I always try to use new filaments in my projects. It just stayed on the side. This material has been stored in a dry and cool place in the cupboard away from the sun. Apart from a small amount of stringing, there hasn't been any problem. We focused on the subject stringing problems like visual and more so printing issues here, but some filaments that have absorbed moisture become stale and even exposed to sunlight begin to lose their mechanical properties. It cuts resistance in many ways, so I advise you remember this when storing your filaments. How do we store our filaments? If the environment is not very humid, store in a cupboard in its own box and with silica gel. You can dry your filaments like PETG, TPU, which are prone to absorb moisture before using them. If the environment is very humid, or if you often use support filaments such as PETG, PA12, TPU, wood additive PLA, or water-soluble PVA, you can store your filaments by making airtight boxes yourself and putting silica gels that absorb moisture inside. Another alternative is vacuum bags. Buying such filament storage bags and storing your filaments in vacuum bags with silica gel when you are not using them will also extend the life of your filaments. Or you can still use different vacuum methods yourself. That's all the knowledge and experience I have on the subject. I hope it has been a useful video for you. If you want to buy the filament, printer, or other products I use in the video, I will add the product links to the description section below. May your printer run smoothly and your printings be flawless. See you in the next video. Goodbye.